So this is Pre-E3.4, which is a review of linear inequalities. When we solve inequalities, there's two ways that we can represent the solution. Well, three ways really, because we can graph it. We can graph it, we can write it in set notation, which my math lab refers to as solution set. Okay, the solution set is the set of all x's such that they satisfy a given statement or a given solution. Okay, and right here in bold, this is what that looks like. Okay, they do curly braces and they put all x's, that's what the x is for, such that, that's what this line means, and then you put in the solution to the inequality. So there's some examples here. If we ended up with like x is less than 17, we would do the set of all x's such that x is less than 17. Okay, and then I did some other ones too. X is greater than or equal to -5. Also, if your variable is something other than x, make sure in your solution set you use whatever variable the problem gave you. So here, if we were dealing with y's, we would put the set of all y such that y is greater than 3. Okay, so that's the solution set or the set notation. Interval notation is the other way we express our answer, which is the span of all values that satisfy the given inequality, or what we get when we solve it. And we use parentheses or brackets depending on if we're including a value or not including a value. So I'm just using these ones from above. So if I were to get something like x is less than 17, that means I'm starting at -infinity and going all the way up to 17, but notice here, since it's a strict less than, I'm using a parenthesis on 17. Okay, so if I wanted to graph this right at 17, if it's everything less than 17, it's everything over here and not including 17. Okay, same thing with this next one. If I have greater than or equal to -5, okay, on my graph I would have a -5, and I'm going to the right because it's greater than, and it's including that 5 because it's greater than or equal to. So we would write that one as starting at -5 with a bracket and then going on out to +infinity. Okay, and then the same thing with this last one. Here it says y is greater than 3. So from my 3, I would be shading to the right. Because it's strictly greater than, I'm not including the 3. So I would use a parenthesis. Okay, so this would be 3 on out to infinity. Okay, so these are the three ways we're going to represent our answer. We're going to write the solution set, which is our set notation. We're going to write interval notation, and then we're also going to graph it. Now on your graphs, I don't care if you want to use parentheses or brackets, or if you'd rather use open and closed dots. Either way is fine with me. Just do it consistently and make sure you know which symbol and which dot means what. Okay, I think your assignment for this section, I think all of the problems I assigned use parentheses and brackets, so that's how I'm going to work it out in the notes so that it correlates nicely. Okay. The other thing I want to point out really quick before we get into solving is that we're going to solve inequalities exactly the way we solve equations. There's only one little change, and that is when we're solving inequalities, when you multiply or divide by a negative, okay, only by a negative, you must reverse the inequality symbol. Okay, so in other words, let me show you an example of why we have to do that. We all agree that -1 is less than, say, 10, right? -1 is less than 10. If I were to multiply both sides by -1, okay, if I multiply this side by -1 and I multiply this side by -1, that would give me +1 is less than -10, which is false, right? 1 is not less than a negative. So anytime we multiply or divide by a negative, we have to remember to flip that inequality symbol or reverse it. Okay, so make sure you remember that when you're solving these, because it will make a difference in your answer. Okay, it's only when you multiply or divide specifically by a negative. If you multiply or divide by a positive, you don't have to worry about it. So let's look at some. Solve the following inequality and graph the solution set. So I'm going to do all three answers. So the first thing I want to do, excuse me, is I want to solve for x. Now most of the time we always say x is less than 1, x is greater than or equal to 7. We always write our x first. So since we write our x first, I'm going to go ahead and solve these by moving my x's to the left. So I'm going to subtract 3x from both sides. When I subtract 3x from both sides, I end up with negative 2x plus 2 is less than negative 2. And then I'm going to move this positive 2 to the other side by subtracting. So I have negative 2x is now less than negative 4. Okay? And then the last thing I have to do is divide off that negative 2. Now remember, I'm dividing by a negative. When I divide by a negative, that flips my symbol. So the way that I remember is I always draw a line through my symbol. I slash it out so that when I rewrite my new step, I remember to reverse it. So this leaves me with x is now greater than positive 2. Okay? So I'm going to write my solution set, which is the set of all x's, such that x is greater than 2. Okay? On a graph, I would need a 2. If x's are greater than 2, that means I'm shading to the right. And then since it's strictly greater than, I'm not including the 2, so I'm going to use a parenthesis here. Okay. So my interval notation, the furthest to the left I can go is that parenthesis that's at 2, on out to the right, which is going to go out to positive infinity. So these are my 3 solutions. Okay. Let's look at another one. On this next one, same idea. I want to go ahead and move my y's to the same side. I'm going to move them specifically to the left so that when I solve it, my variable, it'll just be y is whatever in my answer. Okay? I always want to move my variables to the left when I do inequalities so I don't get confused. So I'm going to subtract 21y from both sides, which gives me 6 minus 26y is less than or equal to negative 9. Then I'm going to move my 6 to the other side by subtracting, which gives me negative 26y is less than or equal to negative 15. And then the last thing I need to do is divide my negative 26 off. Now I'm dividing by a negative. When I divide by a negative, that reverses my symbol. So I'm going to mark it out. And my next step, it's now going to be a greater than or equal to. Okay. So that means y is greater than or equal to 15 over 26. Don't give me decimal answers here. Just leave it as a reduced fraction. Okay? So my set notation here would be the set of all y, because we're using the y variable, such that y is greater than or equal to 15 over 26. Okay? And then I want to go ahead and graph it. So I go to wherever 15 over 26 is, which I'm just going to stick it right there. And if I'm doing greater than or equal to, I'm shading to the right because it's things bigger than 15/26. And since I'm including it, I'm going to use a bracket. Okay. So my interval notation would be that bracket at 15 over 26 on out to the right, which is going to keep going out to infinity. Remember, we always use parentheses on our infinities. Okay. All right, I have a few more to show you, and then y'all can get started. All right, so here again, I'm going to move my y's to the left, so I'm going to subtract 20y from both sides. So I end up with 5 minus 23y is less than or equal to negative 12. And then I subtract 5 from both sides, which gives me negative 23y is less than or equal to negative 17. And then the last thing I have to do is divide off my negative 23. Now here I'm dividing by a negative. When I divide by a negative, that reverses my symbol. So now I end up with y is greater than positive 17 over 23. So that gives me y, for my solution set, the set of all y's such that y is greater than or equal to 17 over 23. Okay. And then I graph it. So I'm going to just say 17 over 23 is here. If I want greater than or equal to, I'm shading to the right, and I'm including that value with a bracket. So the furthest to the left I can go is 17 over 23 with a bracket. Furthest to the right I can go is positive infinity. So those are my 3 solutions. Okay. In my math lab, it may not ask you to enter all 3. It may just ask for the graph, or it may just ask for interval notation, or it may just ask for the solution set. So what I do is when I work these out, I think it's a good idea to just go ahead and list all three and then look at the computer and see which one it wants. Okay? That way you're prepared. All right, let's look at another one. This one's a little bit nasty. It needs some simplifying. So before I can solve for x, I need to go ahead and distribute out all these quantities. So on the left-hand side, when I distribute 6x, 6x times x is 6x squared. 6x times -3 is -18x. Okay, and then on this side, I'm going to go ahead and distribute out these two quantities first, and then whatever that equals, then I'll distribute the 2 in. So 3x times x is 3x squared. 3x times 4 is -12x. -1 times x is -x. Excuse me. And then -1 times -4 is +4. Okay, so then I'm going to go ahead and distribute in my 2. So 2 times 3x squared is 6x squared. 2 times -12x is -24x. 2 times -x is -2x. And 2 times +4 is 8. So I want to go ahead and simplify. And notice, if I have an x squared, that tells me I might have to factor. And if I have to factor, everything needs to be on one side. So I'm going to go ahead and start moving things, which if I were to move the 6x squared by subtracting, look what happens. It actually cancels off of both sides. So I end up with -18x is less than all this stuff on this side. And since I have two x terms on this side, I'm going to go ahead and combine my -24x and my -2x, which is -26x plus 8. So I don't have to factor because I don't have an x squared term. So I'm going to go ahead and just move all my x's to the left. So I'm going to add 26x to both sides, which leaves me with +8x is less than 8. Okay? And then all I have to do is divide off my 8. Now notice I'm dividing by a positive. So anytime you divide by a positive, that doesn't do anything to your symbol. It still stays a less than. So this gives me x is less than 1. So my solution set would be the set of all x's such that x is less than 1. And then I'm going to go ahead and graph it. So here's my 1. If it's less than 1, it's going to be to the left of 1. And it's strictly less than. So I'm going to use a parenthesis because we're not including the 1. Which means that my interval notation, the furthest to the left would be -infinity. The furthest to the right would be my 1 with a parenthesis because we're not including it. Okay. All right, I have one more. And this one you can solve however you like, but I suggest solving it by getting rid of fractions first because fractions tend to screw everyone up. So what I'm going to do is I'm going to go ahead and clear fractions. I'm going to write over here. Clear fractions using the least common denominator, which in this case 4, 6, and 3 are all divide into 12. So my least common denominator here is 12. So I'm going to go ahead and multiply every piece by 12. Okay, so 12 times -5, 6 plus 12 times 1/3 w. And notice the reason I'm doing that is because now I can reduce my fractions away. Because here 4 goes into 12 3 times. So I'm left with 3 times -3w is greater than or equal to. And notice I multiplied by a +12. If I multiply by a +12, that doesn't affect my symbol. On my next term, 6 goes into 12 2 times. So I have 2 times the -5 from my numerator. Plus, my last term, 3 goes into 12 4 times. So I have 4 times the 1w that's left. Okay. So when I multiply these out, I get -9w is greater than or equal to -10 plus 4w. And now this is something much easier to solve. So I'm going to move my 4w to the other side by subtracting, okay, which gives me -13w is greater than or equal to 10. Excuse me. And then I just divide off that -13. Now remember, when I divide by a negative, that's going to reverse my symbol. So now it's going to be greater than or equal to. So w is greater than or equal to +10/13, which means that my solution set would be the set of all w such that W is greater than or equal to 10/13. And then I'm going to go ahead and graph it. Put 10/13 on there. Since it's greater than or equal to, I shade to the right, and I'm including 10/13, so I use a bracket, which means my interval notation, the furthest to the left I can go is 10/13 with a bracket. The furthest to the right I can go is positive infinity, always with a parenthesis. Okay. All right, so that's the end of Pre-3.4. So you should now be able to complete that assignment on My Math Lab. Let me know if you have any questions, okay?